Imagine the cloud as one giant, crowded city. Millions of servers, all sharing the same space. Your app and your data are sitting right next to total strangers. Not a great feeling, right? So how do you get your own private, walled-off area inside that crowd? That's exactly what a VPC gives you. Welcome back to Kiran Tech AI. Today we make VPC really simple. Your own gated community in the cloud. Walls, gates, roads, and guards. By the end, you'll know every single piece. Let's start. So what exactly is a VPC? VPC means Virtual Private Cloud. It's your own private section inside AWS, like a gated estate inside the big city. AWS owns the city, but this piece of land, completely yours. You decide what gets built and who gets in. Your neighbor's traffic can never wander into your space, and yours never leaks into theirs. That's the most important word here. Isolated. By default, your estate is completely sealed. Every server and every database you create will live inside these walls, safe from strangers, safe from noise. Sounds good? Then let's build this estate together, piece by piece. Step 1. Claim your land. You pick a range of private addresses called a CIDR block. It looks like this, 10.0.0.0/16. Looks scary? It's really simple. The first part, 10.0, is fixed. Think of it as your estate's name. The rest is free. Those are the addresses you'll hand out to everything you build inside. Watch this. A new server is born, and it instantly picks an address from your range, like a new house getting its plot number. And the slash number, that's just the size of your land. /16, 65,000 addresses. /24, 256. /28, just 16. One rule to remember, smaller number after the slash means bigger land. Pick it big. Resizing later is painful. Step 2, the neighborhoods. You split your estate into smaller areas called subnets. Each subnet takes one slice of your address range. Why split it all? Simple, because not everyone should live on the main road. The public subnet faces the street. Your web servers and load balancers live here, the ones that must talk to the world. See their badge? To Internet. The private subnet sits in the back. Your database and app servers live here. Their badge says no direct exit. No way out, no way in. And that's exactly what you want. Now watch this. We build the exact same pair again in a second availability zone. That's a completely separate physical building with its own power and network. If Zone A has a bad day, a power cut, anything, your app keeps running from Zone B. That's called resilience. Public in front, private in back, copied across zones. Perfect city planning. But hold on, a sealed estate is safe, but useless. Nobody can visit your website. So we install the front gate, the NAT Gateway. This is the one and only official door between your estate and the public internet. You create it and you attach it to your VPC. One gate per estate, that's the rule. Now watch the traffic flow. A visitor from the internet walks in through the gate, reaches your web server in the public subnet, and the response walks right back out. Both directions fully open. Your website is now reachable from anywhere in the world, but only through this one gate, only where you allowed it. And the private subnet at the back, still completely sealed. It cannot even see this gate. So what about those private servers? Here's the problem. Your database needs software updates. Your backend needs to call outside APIs, but strangers should never be able to reach them. The answer is a special side gate, the NAT Gateway. It sits in the public subnet, and the private servers quietly send their outgoing traffic through it. Watch the direction carefully. Going out, updates, downloads, API calls, all allowed. Coming in from outside? Completely blocked. It's like the service door of a hotel. The staff slips out for supplies, but no stranger can ever enter through that door. Private stays hidden, updates still arrive, and that's why almost every real setup uses one. One question left. How does traffic know which way to go? Route tables. Think of them as signposts standing at every neighborhood corner. Every subnet follows one table, and each table is just a simple list: destination on the left, direction on the right. The public subnet signpost says, "Going to the internet? Take the front gate, the Internet Gateway." The private subnet signpost says, "Going out? Use the side gate, the NAT." And for traffic between neighbors inside the estate, that local road is built into every VPC. It just works automatically. Right signpost, right subnet, and every packet finds its way home. And finally, the guards. There are two of them, and they work very differently. Meet Sadie, the security group. She's the personal bodyguard standing at each house, attached to every single server. Sadie only has allow rules, like let web traffic in on port 443, and she's smart. Let a visitor in and she remembers them. The reply walks back out automatically. That's stateful. Now meet Nax, the network ACL. He guards the border of the entire neighborhood, the whole subnet. Nax has no memory at all. Every packet in and out gets checked against his numbered rule list. That's stateless. Sadie guards each house, Nax guards the street. 2 layers, that's real security. And that's the whole estate. Let's read the map one last time. The VPC, your walled estate. The CIDR block, your address range, your land. Subnets, your public and private neighborhoods. The gateways, your front gate and your side gate. Route tables, the road signs at every corner. And security groups and NACLs, Sadie and Nax, your 2 guards. Your own private network, isolated, structured, and secured by you. If this made VPC finally click, hit like and subscribe. Next, we launch EC2 servers inside this very estate. See you there.